Alright, so in this video, we're going to go through sample question 65 from the Society of Actuaries ExamP list of sample questions. The question reads, the owner of an automobile insures it against damage by purchasing an insurance policy with a deductible of $250. In the event that the automobile is damaged, repair costs can be modeled by a uniform random variable on the interval 0 to 1500. We need to calculate the standard deviation of the insurance payment in the event that the automobile is damaged. All right, so what I want to note before even getting into this is a very important setup to be comfortable with. The idea of having a situation with a deductible or a limit, like where the loss is exponentially distributed or uniformly distributed, I personally feel it will definitely show up on the test. You are going to get a setup like that, so it's important to be comfortable with this kind of situation. We are asked to calculate the standard deviation. So this next setup should be something you're very comfortable with. Standard deviation of some random variable. In this case, I'll call it y, right? I'm going to refer to loss as the random variable x, whereas the payment made by the insurer as y. So we need the standard deviation of y. That's equal to the square root of the variance of y. And of course, we should all know the variance is equal to the expected value of the second moment of y. The second moment of y, which is the expected value of y squared, minus the first moment, the expected value of y squared. So ultimately, we just need to find the first and second moment of y, and we will have our question, or we'll have our answer. Now, we're given information about x, right? The loss, it's uniformly distributed, and we're just told that the payment, y, has a deductible of $250. So let's go about building what y should look like. When you have a deductible, if your loss is below that deductible, your payment made by the insurer is 0. Okay, and if your loss exceeds the deductible, the cost is the loss value minus the deductible. That's what will be paid by the insurer. So we have y is equal to, it's going to be a piecewise function. It will be 0 anytime your loss is below the deductible of $250, less than or equal to $250. The payment will be whatever the loss is minus the deductible for any time you exceed. So x must be greater than $250 in this situation. All right? Now, what's important to note is y is a function of a uniform random variable. Y is itself not a uniform random variable. Because I mentioned that because there is a very easy way to compute variance of a uniform random variable. It is a very straightforward formula that you could memorize. That is not applicable here. So, how do we get the expected values? Well, the expected value of y is a function of x, and that's going to be equal to the integral over the entire range 0 to 1500 of the function y, right, multiplied by my density function. And because this is a function of x, my density function is 1 over 1500. I should mention where I'm getting that from. From this uniform random variable, that should be memorized, right? The density of a uniform random variable is 1 over the upper bound, in this case 1500, minus the lower bound. And one thing I want to note, obviously not sponsored or anything like that, Coaching Actuaries has for free really, really nice formula sheets. for ExamP and ExamFM and a few others. Okay, I recommend downloading that and using it as reference in the beginning because those definitely help. They're amazing and they're free. You can just go to their website, download it. So we're calculating this expected value. And since it's piecewise, it'll be broken up into two parts for 0 up to your deductible. And in that case, my payment is 0 multiplied by my density, which is 1 over 1,500. Obviously, that's going to become 0 in a bit. And I add that to 250 to 1,500 of x minus 250 multiplied by 1 over 1,500. And dx behind these. I keep forgetting them. I feel like many people do. Luckily, this is not a test that will, take off points for that. So now actually computing the integral. That one's easy. That one's just going to be 0. Okay? This one, integrating this should get you the following. Let me see. 1 over 3,000 times x minus 250 squared. And obviously that's going to be evaluated from 250 to 1,500. And let me just plug that into my calculator real quick. Like I mentioned in all my videos where I'm going to take time actually putting things into a calculator, I don't do the questions beforehand because the process of me solving them I think is important for you to see. This is how you'd go about it in an exam setting. Okay, and that is equal to a nice round number, 521. All right, now I'm going to grab a separate sheet of paper, and I don't think I'll need that much room, so I'm going to use paper that doesn't have a lot written on it. Save the environment or whatever. Don't call me a hero. I'm not. Okay, so now we found the first moment. Next job is to find the second moment. So expected value of y squared. And that's going to be, once again, the integral from 0 to 250 of 0 squared multiplied by 1 over 1,500 dx, mustn't forget that, added to integral from 250 to 1,500 of 1, I was about to do the 1 over 1,500 first, but just for consistency, x minus 250 squared times 1,500. Okay, and this becomes 0. This integral, just to do a quick calculation, becomes 1 over 4,500 multiplied by x minus 250 raised to the third power. And that's evaluated from 250 to 1,500. And all I'm going to do is once again compute that. And we get quite a larger number. 434,028. So now that we've got the first and second moments, we plug them into the formula for variance. So that's 4. So variance of y is equal to 434 028 minus 521 squared, and that's equal to 162,587, and the standard deviation of y is equal to the square root of the variance of y, which we found here, and that's easily 403. And let's see what answer choice that lines up with. Answer choice B. All right, so this is admittedly a trickier problem. So let me go over what the important notes are, because I think there's a lot that can be learned from this. Okay, now the question gives us the situation of a loss modeled by a uniform distribution, and then it gives us a insurance policy with a deductible. We need to create a function to represent that payment, because it's not the same thing as the loss due to the deductible being in there. And that payment is a function of our loss. It's not the same thing as our loss. And I want to hammer this home. Our loss is uniform. The payment is not. So rules of uniform distribution don't directly apply to our payment in the same way they would apply to the loss. Now, once we have this function, we're able to, at that point, calculate expected value, right? And that should be somewhat more straightforward after that point, but it's this setup, being able to set up this function, that's going to be crucial to solving the rest of the problem. If there's any questions, anything you want me to clarify, especially for this topic, leave something down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That absolutely helps me out. And if you want to see more questions like this, I have a playlist. The sample questions, just me working them out. But other than that, good luck.